Good morning to everyone. This is Dr. Nagaraju Pendam. In this video, we are going to discuss one more important question from the central force motion only. So that is very important. So many examples are there. Yesterday also I told in YouTube a central force from the central force motion what I told in the yesterday also once you have to take so what I told in yesterday also, that is the gravitational force is a central force, electrostatic force is a central force, a alpha particle trajectory with the nucleus is a central force. Like that, so many central forces are there. There is a restoring spring force also central force. The central force is a force to a line joining to the fixed point towards the fixed point. Such type of force is a central force. In IITJAM 2023, one question they are asking. What is that question? Today in this class we will see. Before going to explain this question, you please like, share and subscribe our YouTube channel and download our app if you are ready to interested to crack the physics exam or to learn the physics concept. You subscribe our channel and you listen in our YouTube channel. You have to circulate to your friends also. Your circulation and your views and your watchover will give the boost to us to teach to you. So that is our ultimate goal, to canvas the physics, whatever the physics is there in CSIR and GATE, those things we are teaching to you. Once you have to see, in IITJAM 2023, there was a question for a particle moving in a general central force field. For a particle moving in a general central force field, which of the following statements are true? Which of the following statements are true? Once again, you have to read the question 2-3 times. Then you able to understand what they are going to ask. So that is very important. For a particle moving in a general central force, which of the following statements are true? Which of the following statements are true? First ones you have to see. The angular momentum is a constant in the motion. The first option they are giving, the angular momentum is a constant in the motion. They are asking under the central force. Kepler's second law is valid. Kepler's second law. What is the Kepler's second law? dA by dt is equal to, so h by 2 or L by 2m. This is the Kepler's second law. The aerial velocity travel sweeps out in equal, so equal areas and equal time it will be sweeps out. So that is the, so Kepler's second law. The motion is confined to a plane. The motion is confined to a plane means orbital angular momentum is perpendicular to the angular momentum, perpendicular to the position. What is the Kepler's third law? Kepler's third law is T square is directly proportional to R cube. This is the time period versus the radius of the body. So that one you have to take, whether it may be sun or earth, whatever it may be, you have to concentrate, you will get it. Now one option I have to explain to you. Once you have to see here, for option A I am coming. From option A, how we have to take under the central force field, under the central force field, which one we have to write? Under the central force field, under the central force. So now we are going to take it as a tau is equal to dl by dt. Tau is equal to the rate of change of angular momentum. This is the Newton's second law under the under the rotational motion. Newton's second law under the rotational motion. Under the central force, tau is equal to r cross f. Tau is equal to r cross f. But under the central force, f is equal to f of r into r bar, f of r into r cap. Under the central force, f of r into r cap is equal to r bar by r. So therefore, you have to take f of r is divided by r. You have to take outside, r cross r is there. So there is going to r cross r is equal to 0. if it is tau is equal to 0, is equal to dl by dt. So if dl by dt is equal to 0, L is equal to constant. So therefore option A is correct. The angular momentum is constant under the central force. Clear? Now I am going to the option B. So what is the option B? The radial velocity dA by dt is equal to the radial velocity of the particle. Suppose you have to take the particle. So now the particle at a fixed point. Now this is the position of that particle, is the R is there. There is a arc. This arc you have to take it as a, if you have to make it as a curve, you have to concentrate. So you have to concentrate d theta, smallest one, r d theta we have to write here. So therefore what we have to write, dA by d theta is equal to 1 by 2 into r square into d theta by dt, 1 by 2 into r square into d theta by dt. dA by dt is equal to 1 by 2 into r square into theta dot. R square theta dot is equal to, but you know one thing, L is equal to m r square theta dot, m r square theta dot. So therefore r square theta dot is equal to L by m. So therefore what we have to write here, so dA by dt is equal to L by 2m we have to write, or r square theta dot is equal to h also. So therefore h by 2 also we have to write. So therefore this is the Kepler's second law. This law we also call it as a Kepler's second law. The aerial velocity sweeps out in equal interval of time. So that is the equal sweeps out. Equal area is sweeps out. This is what, which law it is? Kepler's second law. Clear? Now the third option I am going. So what is the third option? You have to observe L and R in terms of the L and R. So L is equal to what we know, R cross P. L is equal to R cross P. P is the momentum. Now L dot R, you have to find out the dot product of these two. L dot R is equal to R cross P dot R. R cross P dot R is equal to R cross R into P. When R cross R is equal to 0, 0 into P, 0 into P is equal to 0. So therefore from this L is perpendicular to R. Angular momentum is perpendicular to R. If you have to take a, so radius vector R, so when it will be angular momentum perpendicular, so if it is plane, then only it will be acted as a plane. This is the R and this is the L. It is 90 degrees. 90 degrees means it confined into a plane. It is confined into a, which one it is? It is confined into a plane. So a plane, xy plane, if you have to take yz plane, you have to take any, so zx plane you have to consider. So therefore that plane is 90 degrees to one another. Now one more thing you have to take, option D. What is the Kepler's third law? T square is directly proportional to r cube. This T square is directly in r cube, is not concerning the central force portion, right? Central force motion. Clear? Like this you able to get. So based on this, what we have to write? Option A is correct, option B is correct, option C also correct. So option A comma B comma C are correct options. Option A comma B comma C are correct options you have to take. So the like this you are able to find out the answers. The angular momentum is a constant of the motion. Kepler's second law is valid. The motion is confined to a plane. That Kepler's third law is not valid, but here valid is given. So that's why option D is not correct. Clear? Like this we have to solve in our examination. If you really likes my teaching, I'm informing to you. We started the CSR and GATE physics classes in our app. If you really like my teaching, you able to understand my way of teaching, you are really getting into your mind my subject, so then you able to take these courses. CSR and GATE physics, DL physics, JL physics courses are going to have going to conducting in our app. So those courses you have to see. First you download our app. That the app is Quantum Online Academy app. After downloading our app, go to the Play Store. Once you have to go to the Play Store, our courses will appear like this: CSR and GATE physics course, JL physics course, DL physics course. Whether it may be JL or DL, the live plus recorded classes are available. These live plus recorded classes are is going to conduct. So now mathematical methods of physics. If you want to take the mathematical methods of physics, this paper is completely finished now. Mathematical methods of physics. You want to take the mathematical methods of physics, only mathematical methods of physics you have to take. Now the classical mechanics is going on. Which paper is going on? Classical mechanics is going on. If you want a classical mechanics, so now live also is available in between the 6 a.m. to 8 a.m. So there is a class every day 6 a.m. to 8 a.m. So for this class you have to join. You want to only classical mechanics, you have to join in the classical mechanics also. So I am informing you daily. So please share and like our YouTube channel. Utilize the chance. Get the knowledge in your competitive exam purpose. Otherwise, whenever the exam will come, immediately they are going to conduct the exam. You are unable to prepare this whole syllabus. Previously, you have to do the exercise. Then only you are able to success in your competitive exam. Thank you so much.